All right, in this video, just going to do a quick review of our basic graphs and their domain and range. So the basic parent functions or basic graphs, whichever word you want to use. The first function that I think of is f of x equals x, which is our identity. And it's called the identity because it keeps things the same. So just a quick table. If I plug in a 1, I get a 1. Plug in a 0, I get a 0. Plug in -1, get -1. That's what we mean by identity. Everything stays the same. So if I want to graph this guy, I'm going to have to plot the point. Let's put a couple grid lines on here. 1, 1, 0, 0, and -1, -1. Okay, now I just chose these numbers. You could pick whatever x values you want, and then you plug them in here. It's kind of a boring function. You could plug in 271, and you'd get 271 back, but I wouldn't want to graph that. So I normally pick small numbers. Don't forget to pick negatives. A lot of people forget to do that. And so this gets you the starting idea of what our graph will be like, and it's a line because the x doesn't have any powers or anything. So I can just connect these dots, and I have my first graph. So what you should be able to do is identify that this function is called the identity, and this is what it looks like. But again, the graph or the table that we made can help you get those points. Now the next function that we have, f of x equals x squared. This is our squaring function, or sometimes called our quadratic. And so it takes inputs and squares them. So if I put in a number like 1, 0, -1, 1 goes in there, it gets squared, it turns into 1. 0 goes in there, it gets 0. -1 gets in there, it gets 1. And so this one, it looks slightly different because when we plug in negatives, it gives us positives. It also grows kind of fast. So if you plug in just a couple more to see, 2 squared would be 4, and -2 squared would also be 4. So if I'm trying to plot my points, I know I have 1, 1, 0, 0, -1, 1. And then at 2, I'm going to be all the way up at 4. So you can kind of see how this is going to grow fast. But again, the idea is that we're starting to memorize that, oh, squaring grows stuff faster. So it's going to be a little curvy here, and it's called a quadratic. So we need to know those 3 parts. The next function we're going to look at is f of x equals x cubed. This is our cubic function. Now this one, if you plug in 1, 0, -1, 1 cubed is 1, 0 cubed is 0, -1 cubed is -1. This looks just like our very first function. And so you might want to plug in a few more points. So these are the major ones. But if I plug in like a 2, look what happens. 2 cubed is 8. All of a sudden that's growing really fast. So if I were to even graph that, you can kind of see it's like way up there. And -2 gets me -8. So it's going to be somewhere right down there. And so you can kind of see this shape forming, kind of like S, I don't know, looking thing. Oh, one way to kind of help you remember it is it kind of follows the equation as well. Because what some people start to do is mix it up with this guy, which is the cube root function. So this function goes kind of the opposite way. It asks for, what can you put in here? And then say you multiply it 3 times to get that number. So if I put 1 in, cubed root of 1 is saying what times what times what? 3 times gets you 1. Well, that's kind of easy, a 1. 0, cubed root of 0, what times what equals 0? Again, kind of boring. -1, same thing, -1, -1, -1, multiply it together, you get -1. So to be a little bit more exciting, I can't plug a 2 in because there's nothing times itself 3 times that would make a 2. That's whole and nice. It is a decimal, which your calculator can approximate. But for us, the next cubic number would be an 8. The cubed root of 8 is 2. And again, that's because 2 times 2 times 2 equals 8. And so this one actually takes bigger numbers and gives us littler ones. It's the opposite kind of this guy, which takes like a 2 and pops out an 8. So if I take -8, cube root of -8 equals -2. So again, we already went through these lessons, just doing a couple quick sketches to help us out. So I know like the basic graph, and they all start to be the same, 3 dots. This one had 3 dots. This one had 3 dots, but you notice this one was up to +1. It wasn't down here And that's because it squares, which squares will get rid of that negative. And then that one had the 3 dots. So coming back over here, we do need to remember, though, the kind of shape that it's going to have to take. And notice it's taking a big number to pop out something little. So like if I'm over here, somewhere 8, and it's going to give me a 2, and -8 somewhere, and it gives me -2, it's going to look kind of like sideways from the previous one. And again, a way to help you remember that is it kind of follows the flow of that cube root. Now square root, that one's saying what times itself twice only. So it's a little bit different because this one we can't plug in any negative value. So we plug in a 1, square root of 1 is 1 because you're saying what times what equals 1. 0, square root of 0 is 0 because what times what equals 0. Now I can't plug in -1 because that gives me imaginary stuff, which we might not know about yet. I could plug in something like 4, and square root of 4 would get me a 2. So again, 1, 1, 0, 0, that's all looking familiar. I can't plug in anything over here though, because again, that's going to give me stuff that is not defined there. And so then the next thing I have is 4 up at 2. So it almost looks a little like this part of that cube root, but it's growing a little faster because already at 4, it's up at 2. And then it shoots off. All right, next function we have absolute value function. F of x equals the absolute value of x. And now again, this one, I plug in a 1, I get 1, 0, I get 0, -1, I get 1. Because remember, if you put something into absolute value, it makes it positive. And so really it's going to look like our first graph, which was the line, except instead of being negative down here, it pops up here. It's like folding in half. So it's a straight line that way, and then it's going to be a straight line that way. So that's our absolute value function. All right, the next function we'll look at, we have 2 more here. Let's look at the constant function. So I put it equal to 5, but it can be equal to anything really. And all that's saying is all the time the outputs are 5. Like no matter what you plug in, 1, 0, or -1, you're going to be up at 5. And so we're here, 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 and really any value you plug in is going to be getting you a 5. So there's our constant function. And the last one we have is 1 over x. That's our reciprocal function. A reciprocal function just kind of flips it. So if we plug in, again, it's kind of boring. 1, flipping that over means like if you saw it as a fraction, well, what would you have? You'd have 1. If I plug in a 0, well, that's undefined. Because if you flip over like 0 over 1, you get 1 over 0, which is undefined. And then we have plug in -1. That reciprocal would be -1. So maybe something more interesting would be like a 2. Its reciprocal would be 1 over 2. Because again, 2 is like 2 over 1. So its reciprocal is 1/2. The reason that 2 over 1 and 1 over 2 are considered reciprocals is because if you multiply them together, you get 1. So that's the definition of reciprocal. If I have 1/2 and I plug that in, you flip that over, you're going to get 2. So if I plot the points, we have 1, 1. 0 is undefined, so there's nothing to plot there. -1, we're at -1. And just for a little bit more, 2 gets you a 1/2. And what's going to happen is these are going to get closer and closer and closer to the x-axis, not cross it. We're never going to touch the y-axis because we can never be 0. And the same thing's going to happen on the other side as well. So I'm just going to mimic that. And so there's our graph of our reciprocal function. So then the last thing that I want to do is really quick just state the domain and the range. So I'm going to go back to the very first one, which was our identity function. And the domain, that's everything that x can be. So you look and see, oh, well, I could plug in anything I want for x. So that's going to be from -infinity to infinity. You can also see from the graph that it goes forever to the left. So sometimes I'll draw on my grid these infinities to help me out with that interval notation. And so same thing for the range, it goes down forever and up forever. For the quadratic, the domain, again, -infinity to infinity because it goes forever left and right. The range, how low does it go? The lowest point right there is 0 and it does touch there. And then it's going to go up forever to infinity. For x cubed, the domain for this one, -infinity to infinity because it can go left and right forever. our range, negative infinity to infinity, because it goes down forever and up forever. The cubed root. It looks the same as the last graph, just sideways, so it's going to also be the same. Negative infinity to infinity, the range, negative infinity to infinity. So domain and range, they sound like kind of harder words, but really they're just saying what are all the possible x values and what are all the possible y values. And when you look on a graph, the x values are looking from the left to the right, and the y values are looking from the bottom to the top. All right, next function, square root of x. Now this one's got a few restrictions. For the domain, we can't plug in anything negative. We can plug in 0. You can see from the graph that there's a wall on the left side at 0, and it does touch there, but then it goes forever to the right. The range, same thing. There's a floor on there at 0, but it goes up forever to infinity. For the absolute value function, the domain, we can plug in anything we want. You can see the graph goes forever left and right. For the range, bottom up, the lowest point it goes is 0. It does touch there and goes up forever. For the constant function, domain, we go forever left and right, negative infinity to infinity. For the range, it's just here at 5, so we just write the number 5, and it's just set notation here because it's just that single element, that one thing that y can be. Now, the reciprocal function, for that guy, if we're talking about the domain, it goes forever left and it goes forever right, but there's this hole in the middle. We can't be 0. So we're going to stop our interval notation to kind of make that little hole or that gap. And then the same thing happens from the bottom up. It goes forever down and forever up, but there's a hole in the middle. It doesn't cross the x-axis because the fraction 1 over 0 can never ever be 0. A fraction is only 0 if the numerator is. All right, so that was a super quick review. Hope it helps a little bit. Pause, rewind it, check it out again, and I hope that helps.